The situation shows two masses that can slide on a frictionless rod and collide with each other. The data includes a coefficient of restitution of 0.6, and we want to find the velocity of each block after collision. So let's write the law of conservation of momentum, which says total initial momentum mv sub I is the same as net final momentum. And again, observe that these are vector equations and we choose right as positive. So initially I have block A whose mass is 2 kilograms, whose speed is 3 to the right or positive, plus block B has a mass of 0.75. Its velocity is to the left, so I take it as -1, equal to, let's assume both blocks move to the right after collision, so I write them both as positive terms, 2 VA final plus 0.75 VB final, one equation with two unknowns. If I simplify it first before going on, I have 6 minus 0.75, which is 5 1/4, equal to 2 VAF plus 0.75 VB final. So let's call this equation 1. Then if I write the definition of coefficient of restitution, we have E equal to minus, and remember E is 5, so if E is 0.6, so if I plug in the values, I have 0.6 equal to minus VA final minus VB final divided by initial speed of A is 3 minus initial speed of B is -1 because it's to the left. So recall that we can define coefficient of restitution as the ratio of relative approach velocity after collision divided by relative approach velocity before collision occurs. So let's continue with simplification of this equation. The denominator is 4 times 0.6 gives me 2.4 equal to, and let's see, VAF minus VBF. VAF minus VBF. And since I have a minus on the let's see, right side, I want to multiply both sides by minus to have this equation as shown now. So let's call this our second equation. We can solve it for VAF. Then VAF equals to VBF, VBF minus 2.4. So this is our second equation. Then if we plug this into equation number 1, we can then solve for one of the two unknowns. 2 into 1 gives us 5 1/4 equal to 2 VAF, which is equal to VBF minus 2.4, then plus 0.75 VBF. So this is one equation with one unknown. It can easily be solved for VBF. So I have 2 VBF and 0.75. That gives me 2.75 VBF. and then I have 2 times 2.4, which is minus 4.8. If I take it to the other side, it'll be plus 4.8. Therefore VBF can be solved for as, let's see, 5 1/4 plus 4.8 divided by 2.75. So this gives us a velocity for B after collision with a value of 3.65 meters per second. If I plug this number into equation number 2, from 2 we can solve for VAF. So 3.65 minus 2.4 gives us 1.25 in meters per second. So this is the second velocity. Thanks for watching.